Hello students, now I'm going to talk about some string comparison questions in the question bank for chapter 3. So we'll start from this question number 3. So here we want to find the number of character comparisons that we do when we are looking for this pattern goat in this string. Okay, now so let's look at this. So this is my text string that I have, and I want to search for this pattern goat in it. Okay, so you start like this. You compare T with G, and only if these two characters are matching, which means they're the same, then you really compare H and O, right? But in this case, since T and G are not the same, we don't need to compare H and O, right? That's some savings in the number of comparisons you do. Similarly, you don't need to compare E and A and so on. So when one comparison fails in an iteration, we don't do the rest of the comparisons in that iteration. We just move on to the next iteration. Okay, so in each iteration we do certain comparisons. The minimum number of comparisons is 1, and the maximum number of comparisons we do is the length of the search pattern. So in this case it is 1 and 4. One comparison at least, and at most 4 comparisons. So but in this case, since H and G don't match, we still do only one comparison and don't really compare E and O. And then we compare E with G, do one comparison, and so on. Okay, the only time we do more than one comparison is when you have, here you see this G and G match. Since they match, the second characters and subsequent characters could also match. So what we do is we compare this underscore, or you can have a blank space, whatever it is, with this O. And since they don't match, we don't need to compare the subsequent characters, even though this could be, say, A. Since this underscore and O doesn't really match, we don't really care about whether the other characters match or not. Okay, everything should match as it is, right? Okay, so that's the way the algorithm works. Okay, so if n is the length of the text string, which is in this case 47 characters, and m is the length of the search pattern, which is in this case 4 characters, this is what the algorithm tells you. The total number of character comparisons is some x times n minus m plus 1, where x could be anywhere from 1 to m, which is like the length of the search pattern. As I said, we do at least one comparison, okay, to check whether the first character matches with what is there in this text corresponding to the iteration, and at most we could do 4 comparisons, like m comparisons in general, if m is the length of the search pattern. So the total number of iterations we do in this case is going to be 47 minus 4 plus 1, which is 44, right? Now in this 44 iterations, okay, how many iterations we do exactly one comparison? It's going to be 43 iterations, because this is the only iteration. So each time we move the search pattern, that's an iteration. So this is one iteration. We do only one comparison in this iteration, T and G. We don't need to do subsequent comparisons. Okay, so that's one iteration. Then this is second iteration. We compare H and G, just one comparison. And third iteration, one comparison. Fourth iteration, one comparison, and so on. And this is one iteration where we do 2 comparisons. We compare G with G and then underscore with O, right? So that's the only iteration we do 2 comparisons. So out of the 44 iterations, in 43 iterations we do one comparison, and so 43 iterations times one comparison per iteration. And then what we do in the other one iteration, we do 2 comparisons, right? So totally it is 43 times 1 plus 1 times 2, that's going to be 45. So that's the number of character comparisons we are doing. Okay, so that's what it is. Okay, alright, so now let's see question number 4. How many comparisons we do, both successful and unsuccessful, when we do a brute force string matching that algorithm, and we're looking for binary the text string we have is like 1000 zeros, and we're looking for these patterns. So let's see each of them. Okay, so let's start with so you're given, say you're given a text string that is basically 1000 zeros, so you have zeros like this. How many zeros? 1000 zeros. Okay, so your length of the text string is going to be 1000 bits or characters, whatever you want to call them. Okay, and the first A part is going to be 0001, right? So that is going to be 5 bits, right? So let's do this. So you have this 0000000, so on up to 1000 zeros, right? And we are now comparing that with this. Now you see here, okay, alright, so here in this iteration we compare this 0 with this 0, and there's a match, so we then compare this 0 with this 0, there's a match. Then we compare this 0 with this. So we have done 3 comparisons so far. This is the 4th comparison, and this is the final comparison where we compare 0 with 1, and they don't match. So this pattern doesn't really exist in this string for this iteration. So now, so how many comparisons we did in this iteration? We did 5 comparisons, right? And then what we do, we then move this pattern to this position. So we compare now this 0 with 0, compare this 0 with this 0, compare this 0 with 0, this 0, and so on. So we do another 5 comparisons. Okay, so in iteration 1 we do 5 comparisons, and iteration 2 we do 5 comparisons, and so on. Okay, so in the 3rd iteration we do another 5 comparisons, this 0 with this 0, this 0 with this 0, the second 0, then the 3rd, this one with this, and so on, right? And we do that until we could do something like this, right? We compare this 0, sorry, this 0 with this 0, then this with this, right? So in neither of this, in any of these iterations we don't see a match, right? But we still do all the maximum number of comparisons in each iteration, because we have a match for the first 4 characters, one in the last character it doesn't match. Okay, so as I said, the number of iterations we do is going to be n minus m plus 1, where n is the length of the search of the string, and search pattern is 5 characters long, plus 1, so it's going to be 996 iterations. In each iteration we do, in this case, how many comparisons? We do 5 comparisons. So the total number of character comparisons we are doing is going to be what, 996 times 5, which is going to be 4980 if you do the math. 996 times 5 is 4980. Okay, so that's what is your final answer. Okay, so let's look at this. You have Now the string is still the same. You have this 1000 zeros, and what you're looking at is going to be, oops, did I copy it? Now what you're going to look at is search pattern like this. Okay, so now looking this B part. Now as you see here, we do this iteration one comparison. It's like that goat problem where the first character itself doesn't match. So it compare 0 with 1. Since they don't match, you don't really need to compare this 0 with this 0 and this with this and so on. So in each iteration we really do one comparison, compare the first character with the first character, and they don't match, so just move on. So compare this character with this character and they don't match, so you just move on. 0 with 1, they don't match, move on. 0 with 1, don't match, move on. So you do that all the way till the end, where you compare the 0 with 1, they don't match, right? So we don't do any of the rest of the comparisons in that iteration. So again, the number of iterations we are doing is going to be that 1000 minus 5, this is 5 characters plus 1, so that is still 996 iterations. And in each iteration we are doing one comparison. So the total number of comparisons we are doing is going to be 996 times 1, which is 996 comparisons. Okay, so that's the answer for this part. So let's do the third one. So this is now again the string, and now we are looking for something like 0 1 0 1 0. So now you see we do one comparison, they match. The second comparison doesn't match, right? And since they don't match, we don't need to do the rest, so we just move on. So we compare this 0 with 0, this 0 with 1, they don't match, so we move on. So like that we go up to this point where the first character matches and the second character doesn't match. So again we do how many iterations? N minus m plus 1 iterations, which is again 5 characters, so 996 iterations, and two character comparisons per iteration, so that is going to be, so totally 996 times 2, that's going to be 1992 comparisons. Okay, hope this clears everyone how to do such kind of problems. Now let's see this fifth question on again string comparisons. So here, for example, you're given a text string like this, and you want to find out how many substrings are there in this text string that start with an A and end with a B. Okay, so in general, you are given a text, you want to find the number of substrings that start with, say, character A and end with a different character B. Okay, and you want to design a theta of n algorithm for this problem. Okay, now the logic I suggest to use for this particular problem is, okay, since we want to start with, find the substring starting with one character and ending with a different character, what we have to do is, let's go with that example. We have, let me see if I can copy this. Okay. Alright. So you want to find all sorts of substrings that start with an A and ending with a B. So it could be the whole string could be a substring starting at the ending with B, or it's just even A, B could be a substring. So we have to find all sorts of substrings. Actually, we want to find the number of such substrings. We don't want to really find the actual substrings. We want to find the number of substrings starting with A and ending with B. All right. So the logic is we do one traversal or go through this list once, okay, left to right, character by character, and the logic is we want to find the substrings or count the number of substrings that end with a B, right? So everywhere we see a B as we go from left to right, everywhere we see a B, we of course what we have to also do is keep track of the number of A's we have encountered so far. So everywhere we see a B, the number of substrings starting at the end ending with B is the number of A's we have seen so far when we hit that B, right? So let's do this. So let's keep two counters. The number of A's encountered so far and the number of substrings of the form A to B. So when we are at D, there's no such thing, so this is going to be 0 and this is also going to be 0. Now when we look at A, right, this A, we are going to say that we have seen 1A. Then when we are at this A, the second A, we are going to say we have looked at 2 A's, and then X is not A or a B. Now we are looking at a B, right? So the algorithm is, once you encountered a B, just add the number of substrings that you have found so far with the number of A's you have encountered so far. That's going to be then 0 plus 2, it's going to be 2. So 2 is the number of substrings from A to B you have encountered on this kind of string from D to B. Okay, so then continue. So this is a third A you have seen so far, and this is now another B. So once you hit a B, the number of substrings you have seen from A to B is going to be the number of substrings you had so far seen, which is 2 before, right? And then this 3, number of A's, which is 5. So look at this. For this part of the string, this A to, like, this is one substring, right? The other substring is this, and for this B you have this is one substring, this is another substring, and this is another substring. So 3 substrings for this B, right, and 2 substrings for this B. So that's what is this 5. Then keep going. When you hit this A, you have seen it, the fourth A. When you hit G, is not matching. This B, again, what you have to do, replace the number of substrings by whatever you have seen so far plus the number of A's. So that's going to be 9 substrings totally. Okay, so with respect to this B, it's going to be actually how many? This is 1, and this is 1, right? This is the third one, and this is the fourth one, right? So for this B, you have 4 substrings starting with A, different A's, and then ending with this B. Like that, you had 3 for this and then 2 for this. So everywhere you hit a B, keep track of the number of A's you have encountered so far until you hit that B and add it to the total number of substrings you have, right? So for this B, it's 2 A's before that. For this B, it is 3 A's before that. For this B, it's going to be 4 A's before that. So it's basically 2 plus 3 plus 4. That's what it is. Okay, so 9 substrings. So in general, that's the algorithm. Scan the string from left to right, and keep track of the number of A's you have encountered so far as you traverse it from left to right. And whenever you hit the B, the number of substrings you have seen so far is whatever you have seen so far plus the number of A's. So to start with, it is 0, and then once you see this, it is 0 plus 2, so 2 substrings. Then once you hit this B, it is that 2 plus, you have seen 3 A's by that time, so 3 substrings. And then when you hit this B, you have seen 4 A's by that time, so it is 4 substrings ending at this B. So it is totally 9 substrings. Okay, so that's the algorithm. And for this particular example, this is the number of substrings you see. Okay. And I have also shown it like this. Same thing that I worked out. The number of A's you have seen and the number of desired substrings that you encounter. Okay, as you proceed from left to right. I hope this helps you people to answer some questions on string matching algorithms. Okay, all right, bye.